I mentioned in my video on computer components what RAM is and the role that it plays. In this video, I will be going a bit more in depth into this component, explaining precisely what, why, and how it does what it does by going into the two main subcategories of RAM, dynamic RAM and static RAM. To give a brief refresher, RAM is a bit of a middle ground. Hard drives are very slow but store a ton of data, while processors are extremely fast but store hardly any data. Random access memory is a mixture of the two, a place for large, bulky data and machine code to be temporarily stored so your CPU can grab it and use it faster than the hard drive would be able to provide for it. So let's take a look at the two types of RAM, static RAM and dynamic RAM, often referred to as SRAM and DRAM respectively. Every stick of RAM that you buy is going to have a little bit of both, as they're intended to work synergistically. Here are the main differences between the two from a functional perspective. Static RAM stores less data, while dynamic RAM stores more. Static RAM can be accessed much faster, and dynamic RAM can be changed much faster. Dynamic RAM costs less, and dynamic RAM uses more power. Now let's talk about how each of these work, and then I'll get into the types of things each one is used for. Dynamic RAM stores binary data by using one transistor and one capacitor for each bit. As I mentioned in my video on binary, this code of ones and zeros is what all data and instructions come down to. In dynamic RAM, if a capacitor is holding a charge, it's a 1, and if not, it's a 0. The transistor connected to this capacitor lets the rest of your computer know if the capacitor is charged or not, and it also allows it to be changed as requested. Think of the transistor as what controls what is stored, while the capacitor is where it is stored. The advantages of this are that the transistor and capacitor put together are incredibly small, allowing for millions of them to be present in an area the size of your finger. The problem with microcapacitors is that they lose their charge very quickly. They can only store it for a few milliseconds, and this means that in order to remain charged, the capacitor must constantly be refreshed with tiny bits of electrical current. This results in memory that can't be accessed quite as fast as it could if it were in a constant state. But because this type of memory is constantly refreshed anyways, it makes it easier to make changes in its state from on to off. Now let's take a look at how static memory works. Instead of using capacitors, static memory uses only transistors. But it requires 4 or sometimes 6 of them in order to represent one single digit of binary, and therefore one bit of data. Static RAM accomplishes this by using something called the Boolean method, which is too complex to get into now, but I'll make a video on it in the future. In short, because static RAM requires more transistors to represent a single bit of information, it obviously requires more physical space on your RAM chips in order to do so. This results in less storage space. The advantages of this method is that unlike capacitors, static memory is constantly in the state that it's in. Whether it's representing a 1 or a 0, it remains that way and can be read that way until it's told to change. And this means that it can be accessed much faster than dynamic RAM, which sometimes has to wait for a refresh before it can be read. So we have a high capacity, easy to change, but somewhat slow system of memory, and a low capacity, harder to change but instantly readable system of memory. Why are both necessary, and when is one used rather than the other? As you may have guessed, static RAM is used to store data or instructions that aren't particularly large but need to be accessed frequently and quickly, such as a cache. Meanwhile, dynamic RAM is used for everything else, things that aren't needed quite as urgently or frequently but take up more space. In a way, static RAM does for your RAM what RAM does for your computer as a whole: low storage but fast and reliable access. Meanwhile, dynamic RAM does for your RAM what a hard drive does for your computer. It's not as quickly accessible, but it has far more storage. It's hard to give specific examples of when one is used rather than the other because the difference is determined by very, very low-level operations, things that a typical user isn't really going to have any experience with. Just keep in mind that both are very important for your computer's functionality. That's the general overview of how these two systems of memory work. If you have any questions, don't hesitate to leave a comment, and as always, I encourage you to look more into the specifics. Liking, sharing, and subscribing are always a huge help, and thanks for watching.